Um, let's check the esterification, or we can call it an ester. So esterification is a reaction. So that's why I have mentioned both of them. So esterification is a reaction. So you'll see when we move on to the types of reaction. So ester as the homologous series. So make sure you know the difference between the esterification and ester. So ester is a homologous series, esterification is a reaction. So now to do this thing, first we must know that for us to have an ester, first we must have alcohol reacting with the carboxylic acid, or the alcohol reacting with the acid. So the product is ester plus water. So why are we having water? Because there is sulfuric acid as a catalyst, for example, or the reaction condition. So for us to have an ester, that means we must have an alcohol reacting with the carboxylic acid. So it means that here we are going to have the presence of H2SO4 as the sulfuric acid plus heat. So once you see H2SO4, it means that the answer, or one of the products, is going to be water. So we're going to have an ester, then plus water. So water will be one of the products because there is H2SO4. So sulfuric acid, before we go far, H2SO4, H2SO4, this one, it acts as a catalyst. It acts as a catalyst and also a dehydrating reagent. So dehydrating reagent. So these are the functions of the sulfuric acid, H2SO4. So just know that it acts as a catalyst. It also acts as a dehydrating reagent. Why a dehydrating reagent? It's because at the end of the reaction, one of the products is going to be water. So it will remove water from the reactants. So here, this was going to happen. Let's say we have a structure like this one. Let me put OH. Sorry. OH, and then so here we have this structure. This structure, it belongs under which homologous series? Alcohol. Why? Because there is an OH. So this one you can say it's alcohol. And then plus, let's have this one. So this one, it belongs under which homologous series? You check the functional group. This one is a carboxylic acid. So you can say it's an acid. That's fine. So now let's check. You are reacting alcohol plus acid. So this one, you check how many carbon atoms? 1, 2, 3, 4. So 1, 2, 3, 4. This one is butanol, because the functional group is in carbon atom number 1. And then this one, a carboxylic acid, the functional group is always in the first carbon. So we are reacting butanol with what? 1, 2, 3. So this one is going to be a propanoic acid. So since now we are reacting these two, butanol and a propanoic acid, now let's check what's going to happen. So since we must use the structural formula to write down the balance equation, so let's start. Butanol plus the propanoic acid. So here the structure for butanol already we know. I just want to bring it here. So make sure we show all the bonds and all the hydrogen atoms. So it's butanol plus, I just want to start like this one, the propanoic acid is still the same. So since now we are looking for the product ester and water, so here let's take this arrow as the equal sign. So here we're going to have H2SO4 as a catalyst, and then we're going to have a heat as a reaction or as a condition. So the answer now, we're going to move this one and this one. Since at the end we must have water, that means this one's going to give us H2, this H plus this H and the O, so it's going to give us H2O at the end. So we just know that at the end the answer is going to have H2O. So now let's check. Since we removed this O and this H, this is the structure now. See, this is the first carbon atom, this one, and then the second carbon atom, this one, and then the third carbon atom, the fourth carbon atom. So since now, check, we remove this O and this H and this H, that means now we're going to have O, this is O, this one, and then bond, then this carbon atom with a double bond O up there, and then just like that. So now check, we have a new structure. So this one, this is what we call our ester, this one, and then this one is water, as you can see, H2O. So now what is the name of this one? So the name now, we start with the alcohol. So we name this alcohol as like we're naming a branch. So check 1, 2, 3, 4. So it's going to be butyl. We name it like we're naming a branch, butyl, and then we come this side to the acid 1, 2, 3. So 3 is propan ester, so it's going to be propanoate. So it means that now the name of this ester is called butyl propanoate. So the ending for ester, OATE. So you check the ending of the name. So this one, it means that this structure, it falls under the homologous series called ester. So remember, this is the homologous series. So let's have another structure. Let's say now we are reacting propanol and the methanoic acid. Yes, methanoic acid. So we must use the structural formula to balance this thing, or to write down the balance equation. So you are reacting the propanol and the methanoic acid. So remember, make sure that one of the products is water. Why? Because we have a dehydrating reagent as sulfuric acid, with a heat down there. So now we draw the structural formula. We must draw the structural formula for propanoic acid now. So this is prop, means that we have 3 carbon atoms. This is meth, it means that we only have 1 carbon atom. So 3 propanol, 3 carbon atoms. That means it's going to be 1, 2, 3. So here OH. Okay. So plus, now we must have our methanoic acid here. So C double bond O, then O bond H, then H this side. So this is our methanoic acid. Remember, meth means that it's 1. So it's 1 carbon atom. So we must have this arrow, and then we show that we have H2SO4 as a catalyst or the dehydrating reagent plus heat. And then now remember, one of the answers is going to be H2O. So that means now we must deal with the remaining one. So we remove this one and this one. So now we are left with 1, 2, 3. So this is the first carbon atom, the second carbon atom, the third carbon atom. So now let's check. We removed this one, OH, and this H. That means now we have this O here. So we put the O here and the bond. Then we have this one. So now this is our new structure. So this is our ester now, and then this is our water. And then now let's check. Now we must name this structure now. So we start with the alcohol. The one from alcohol, we start with it, but we name it as like we're naming a branch. So 1, 2, 3. That means this one now is going to be prop, remember 3. So it's going to be propyl. We name it like we're naming a branch, propyl. And then the acid now is meth. That means now it's going to be methanoate. So the name of this ester now, it means that it is propyl methanoate. Let's check another one. Let's say now we're reacting pentanol and the ethanoic acid. So we're reacting the pentanol and the ethanoic acid. So now let's check pent. It means that we have 5 carbon atoms, and then eth, it means that we have 2 carbon atoms. So let's start with the alcohol. Now we draw the structure, because we must use the structural formula to write down the balanced equation. So we start with the alcohol now. So the first carbon atom, the second, okay, we must make sure we have 5 carbon atoms. 1, 2, 3, 4, 5. So we write the hydrogen atoms. So this one's going to be OH. Then plus, let's check ethanoic acid. Eth, it means that we have 2 carbon atoms. So let's start with this one, double bond O. Let me put it here. And then the first carbon atom and the second carbon atom. So remember, for carboxylic acid, the functional group is always on the first carbon atom. So